Okay students, welcome back to another video. In today's video we'll be doing questions related to Hooke's law, work, power and energy. So the first question says, draw a graph of extension against load for spring which obeys Hooke's law. So what does Hooke's law says? We know that Hooke's law says that amount of extension produced in an elastic body depends upon the load. The greater the load, the greater the extension would be produced in the body. So load is directly proportional to extension. That means F, represented by the force, is directly proportional to the distance or extension, replacing proportionality by constant, which is known as spring constant. Okay, and it depends upon the spring, the quality of the spring. So this is what Hooke says to us. So if the something has direct relation, for example in this case load and extension has direct relation, so their graph would look like this straight line. Okay, as long as they obey Hooke's law, their graph would be straight like this. Okay, state the word used to describe the energy stored in spring that has been stretched or compressed. So what kind of energy is stored in a spring when it stretches or compresses? We know, for example, this is a spring and we are just stretching the spring towards, for example, this point. So if we extend the spring towards this point, this energy which would be stored in it, it would be strain energy. And there's another word you can use instead of strain energy. You can also call it elastic energy, because it is a spring is elastic and any elastic body is supposed to store elastic energy when it is stretched or compressed. You can write either of them. You'll get 1 mark for it and 1 mark for this graph. So 2 marks are done. After it, the next question says figure 3.2 shows a model train traveling at speed v approaching a buffer. So this is a train which is traveling towards this buffer, and this buffer will help this train to stop. The train mass is 2.5 kg, is to stop by compressing a spring buffer. The same thing. There is a buffer which is like a spring. So whenever this train will hit the spring, it will stop. After the train has stopped, the energy stored in the spring is 0.848 joules. So the energy that would be stored in spring would be 0.48 joules. For example, this train is moving with velocity v, and we know that something that is moving has kinetic energy. So it would have certain amount of kinetic energy, and whenever it will hit the buffer, it will give all of its kinetic energy to this buffer and come to rest. So all of the kinetic energy would be stored in the buffer this time. So 0.48 joules was the energy of the train, and now the train has given its energy to the buffer. So we can say that the kinetic energy of train was 0.48, that is totally transferred to the buffer. So I can write the kinetic energy formula beneath it. Arranging the equation, 2 would go to that side, it would get multiplied, m would get divided. So 2 times 0.48 divided by mass. So it will give you 0.48 divided by 2.5 kg. Okay, this is very strange. I have never seen a train of 2.5 kg before, but still, if it's a question, you have to solve it. So it would be, after solving all the equation into the calculator, you will get 0.62 meter per second is the speed. You have to take square root of it as well, because there is v square that side. Okay, this will secure your 6 marks. This question says figure 2.1 shows a conveyor belt. This is a conveyor belt. It just slides and then helps the load to lift it some height, and the mass of the package is 36 kg. This box has the mass of 36 kg. Calculate the increase in potential energy of the package when it is raised through vertical height 3.4. So at ground it has height 0, and then when it reaches the height 2.4 meter, what is the increase in its potential energy or change in its potential energy? We know that potential energy is equals to mgh. M is mass, g is gravitational acceleration, and h is height. Okay, we will put 36 in place of mass, 10 in place of gravitational acceleration, because this is always 10 near the earth, and h would be 2.4. Multiplying all these three together will give you 864 joules. Okay, you can write units of your choice. If you don't want to write joules and you want to just calculate the units from this terms involved, so it would be Newton meter. Okay, you can use any optional unit if you want to. Okay, the package is raised through the vertical height 2.4 in 4.4 seconds. Okay, so the previous concept, which involved the energy 864, has been done in 4.4 second. You have to calculate the power this time. Power has the formula of energy supplied or delivered per second or per unit time. So we can just substitute the values in the formula. We know that energy that we have already created is 864 and the time is given by the question. So it would be 864 joules over 4.4 seconds. And when you'll put it into your calculator, it will give you 196 watt. Watt is the unit of power. Okay, and if you want to write unit joules per second, it's okay, it's joules per second. Okay, the electrical power supply the motor is much higher than the answer. Okay, they are saying that 196 is the answer, but the power we supplied to this conveyor wasn't 196, it was much higher. So what happened to that higher power? Why we got 196 as an output? Because we know that the energy we supply isn't totally converted into use. Some of the energy also get dissipated. So the answer is energy is dissipated in form of into the surrounding in form of many other energy. We can say heat energy, we can say sound energy, we can say this is dissipated into friction. That means that also means it is dissipated in form of heat energy. So I'm just writing heat and sound, and if energy get dissipated, it will also reduce the power. So this is the answer. Energy is dissipated into surrounding. Now this question says assume the power available to rise the package is constant. Okay, power is constant and a package of mass greater than 36 kg is raised to the same height. So now this time you're going to take a bigger box, you're going to take a box of bigger mass, and then you would have to raise it by the same height. Okay, and you know the power is constant, the machine is supplying the constant power. So what will happen if you take a bigger box? So we know that power, we have just discussed that power equals to energy over time. And in this case, we have energy in form of gravitational potential energy. So that means it would be mgh over t. I can replace energy by mgh over t. And we know that if power is constant, height is constant, gravitational acceleration is always constant. So we have two things left that can vary. If mass becomes greater, the time would change. Now, how can this time change? Let me just arrange this equation. Time goes to that side, multiplies by power, and g and h get divided this side. So if power is constant, g is constant, h is constant, so I can just replace these constants by proportionality sign. So I can see that mass has a direct relation with time. So if mass is going to increase, the time would also be going to increase. So if you increase the mass from 30 kg, it will take longer to lift that certain amount of mass. So reason is, if mass is increased, it will take longer time, or you can just write it till here, but let me just complete the sentence, to raise the height of the box. Don't have to write all of this equation, you just write the sentence and you'll get your marks. This question says that there is an athlete of 64 gram and she's going to jump on this trampoline. Okay, we know that there's spring attached to the trampoline, so what kind of energy would be stored in that trampoline when the girl jumps? In the spring, we have already discussed it. There is the energy when we just compress the string or extend the string. There is strain energy that is stored in it. Or we can also call that this is a elastic energy that is stored in spring. You can name one of them, you'll get your marks. The next question says that the stretched surface of the trampoline begin to contract. The athlete is pushed vertically upward and she accelerates. At the time t, when her upward velocity is 6, she loses contact with the surface. Calculate the energy, kinetic energy at that point. We know that when the girl pushes the trampoline, the strain energy would be stored into it, and when she puts herself up, all the strain energy would be converted into kinetic energy of that girl. So how can we get the kinetic energy when she is moving with 6 meter per second upward? We can write the formula of kinetic energy first. Kinetic energy equals to half mv square. We will arrange our values according to it. Mass would be 64. Let me check it again. It was written, yeah, it's 64 kg. So I will write 64 in place of mass. And v squared would be 6 squared, okay? Because they have given us the velocity of 6. So doing all the calculation, the kinetic energy that we'll get would be 12,000 joules. Okay, sorry, 1200 joules. So calculate the maximum possible distance that the girl can travel in time t. We know that when the girl started moving upward, she has kinetic energy that was gained from strain energy, and when she'll start moving upward, all of her kinetic energy is going to be converted into potential energy. When she'll reach her maximum height, then she'll start coming backward. So I can write we have to calculate the maximum height, that means distance, the maximum distance she reach. What can we do? We know that these energy are interconvertible, so I will write kinetic energy equals to potential energy, and then I'll write 12,000 in place of kinetic energy that we have just calculated, and in place of potential energy I'll put mgh. Arranging the equation with respect to x, where h would give me 1200 over mg, and then it would be 1200 over 64 times 10. Putting all these value into your calculator will give you 1.8 meters. So this is the final answer. But the next part says that when we did the experiment, actual experiment, the distance wasn't 1.8. The maximum distance the girl reached wasn't 1.8 like we have calculated. What happened? Is our answer wrong? No. Where does why did she cover less distance, less height this time? Because we, in our experiment, we neglected the air friction that was present, but in actual life we know that there is air, there is resistance of air that reduces our energy, so our energy get dissipated. So some of our energy, which kinetic energy we had, which was 1200, is lost in overcoming the friction. Okay, so is lost due to friction. So we haven't used our 100% energy. That's why the girl didn't reach the maximum height, that was 1.8. If there wasn't any friction, if the conditions were ideal, the girl must have reached a distance of 1.8 meter. Okay. Next question says that there is a trampoline spring that are being tested and the extension load graph is plotted. So this is the graph of extension and load. We know extension and load are directly proportional. After point X, the linearity relation doesn't follow anymore. They no longer obeys Hooke's law. Okay, so what is this point after x called? State the name of the point x. The point x is limit of proportionality. It is the point after which your elastic body does not obey your Hooke's law, and the extension is no longer directly proportional to load. State the name of the law that spring obeys in the origin of the graph and the point x. From 0 to x, we know it's obeying Hooke's law, of course. So I am just writing Hooke's law. 1 marks for each of the questions, so 9 marks in total, including all the previous questions. Okay, that's it from today's video. If you have any questions, you can ask me in the comment section, and if you want me to upload more questions related to this topic, you can also let me know. Thanks for watching the video. Take care. Bye bye.